Now, yesterday we were trying to find the hypotenuse length using Pythagoras' theorem. Today we're going to be looking at finding the shorter sides of Pythagoras' theorem. Of a triangle using Pythagoras' theorem. So, all of yesterday, if we had A and B, we were trying to find out what C was going to be. Now, if we have C and B, and we want to find out what A is, we have to try a different methodology. We are going to still use Pythagoras' theorem, but we're going to rearrange it somehow. So let's just take this triangle here for a second. Okay, we have our hypotenuse, which is opposite our right angles, which is 25. It should be our longest side. We have this base length, which is 15. And then we have A here, which we don't know what it is. Okay, if I was to put it in Pythagoras' theorem, c squared equals 15 squared plus A squared. Let's do that again. C squared equals A squared plus B squared, and then we put it in our numbers, which is 25 squared equals A squared plus 15 squared. If we were trying to solve for that, we would go, okay, I want A by itself. So I am going to, actually, you know what? Let's expand these numbers first, because then we're less likely to get confused. 25 squared is going to be 625. 625, A squared, and our 15 squared will be 225. Okay, from here, let's minus 225 from both sides, so that's a manipulation. So therefore, I'm going to be left with 400 on this side. And then if I square root both sides, square root of 400 should be 20. It is. 20 equals A. So what I need to do here is there's one extra step from yesterday, is that we have to minus our B side. We have to figure out what B is, then minus it from both sides. So this is very similar to yesterday, except we're not plussing these sides. We're now minusing and taking one away, and then square rooting. So let's do a few examples. Okay, here, let's start with this one. Our C is going to be 17. So let's start with 17 squared equals A squared plus 15 squared. I'm just skipping writing it out properly, but you understand. So let's do 17 squared is 289 equals A squared plus 15 squared is 225. Now, instead of plussing, which we can't do, we're going to minus 225 from both sides here. So minus 225 minus 225. What is 289 minus 225 equals 64. Okay. 64 equals A squared. Now, if we square root both sides, to get A, the square root of 64 is 8. So A equals 8. Let's pull that up a little bit so you can see. So we should say, therefore, A is 8 units. Okay, pretty easy. If we're looking at, let's quickly do B, C, and D. So B, we've got X equals 10, and we don't know our A, and our B is 7.6. Okay, so if I write that in, let's draw a little line so we separate it. 10 squared equals A squared plus 7.6 squared. So let's run it through. 10 times 10 is 100. A squared plus 7.6 squared is 57.76. Let's minus that from both sides. that gives us a squared on this side. Go 100 minus our answer, gives us 42.24. Okay, I do not know what this is going to give us, but it says to round to 2 decimal place. Let's figure that out. Let's square root both sides, put in our answer. So, if we square root this and square root that, that gives us to 2 decimal places 6.49. Well, that would round up to 10, so that becomes 5, so that becomes 0. So this is 6.50 equals A. Okay? Now, a lot of people get confused with this triangle specifically. If I'm looking at this, this is X, and these two dashes and these two dashes means that these are the same length, just here. So this is X, and this is also X. Now, this one is a little bit confusing, but if you just stick to combining like terms, you should be able to solve it. So remember, this is our C, this is our A, and this is our B. So this squared equals this squared plus this squared. So if we're squaring this length, it will still be x squared, and this will be x squared. So if we do our c squared equals a squared plus b squared, and we replace our c with 3 squared, our x with x squared, and our b with x squared, and then we actually compute the 3 squared, which is 9, and we're like, well, x squared plus x squared, that's just 2x squared, because you've got two of them. They are like terms because they match, because they're x's and they've got squares in them. So this becomes 2x squared. Okay, well, I want to figure out what x is, but I have to unbind it from these squares, the squared and this 2. So I think the first thing I want to do here is, some people might square root it straight away. You actually don't want to do that. You want to get it just by x squared first. So the first thing you want to do here is you want to divide both sides by 2. I'm just doing that as a fraction. That would cancel that out. I'm going to leave this side like this. It does look ugly, but I am just going to leave it like that for now. It could be 4.5, but I'm just going to leave it as a fraction. Now, if I square root both sides, I'm going to put that in my calculator. The square root of 9 divided by 2, that gives me 2.12. Now, this says to 2 decimal places. Actually, in exact form. It actually wants it in this form. So I'm actually going to leave it like that. 9 over 2. That's my answer. Sorry, it says up here, place, given the exact form to part C. So we're doing that. So it'll be 9 over 2. And that's it. That's all we have to do. And the last one, we have the sides. Our C is going to be 13. Our A will be 12. And our base B will be X. So let's put those in. 13 squared equals 12 squared plus x squared. So 13 squared is 169. 12 squared is 144. And x squared is just x squared. Here we want to minus 144 from both sides. What is 169 minus 144? It is 25. So this becomes 25, this becomes x squared. If we square root both sides, 5 equals x, so x equals 5 units. Okay, and this is how we're going to find shorter sides. We're just using Pythagoras' theorem like we did yesterday, but we have to minus that number from both sides, or like the number that we know. Okay, so in this case it's 144. In this case we have to divide it by 2 and just leave it in the exact form. Here we did minus 225, and here we had to minus 57.76. Okay, so it's not that much different from yesterday. It's just you're adding one extra step.